Hi guys, and welcome back to another lesson in geometry. In today's lesson we're going to look at using parallel lines and understanding relationships to solve a series of problems about angles. So what are parallel lines? Well, parallel lines are lines that run in the same direction but never ever touch. Like train tracks, so we have train tracks that run in the same direction but they never touch. They are parallel. So let's just recap vertically opposite. So we have here a vertically opposite angles where these two angles here are the same and these two angles here are the same. Now, when we're talking about parallel lines, essentially what we're doing is duplicating that line. So here we have two parallel lines and a line running through it. That's what we refer to when we talk about parallel lines in angles. When we have two lines that are parallel and a line that goes through it, they are parallel lines in angles. And we can use that to understand which angles are the same. So already we can see here these two are the same because they're vertically opposite, and these two. But these two are also the same. They're corresponding, and we're going to learn that in a minute. And these yellow ones are corresponding, and these yellow ones are corresponding. And so there's lots of different relationships we're going to learn about. So the first things we know are vertically opposite angles. We also know our straight angle equals 180. And there's straight lines everywhere in this, so you have to keep that in mind when we're answering some questions. But some other ones are things like cointerior angles. Now these are the two angles inside of the parallel lines. They make a little bit of a C shape. And we call them cointerior, and they add up to 180. Alternate angles are the angles made by a Z. So here's our Z. And these two here are what we call identical. They're alternate, they are the same, they are equal. And the last one we're going to learn about today are corresponding angles. Oh, that's a bit strange. Corresponding angles would be these two, and this line should continue to run. I'm not sure where it's gone, it's disappeared. But continue to run up there. Oh, there we go. I accidentally added it in. So if we go back to this, these are corresponding angles. So you can see that they're in the same position as each other on each set of line. So here and here. And we have lots of corresponding angles. These two this one and this one are corresponding. They're in the same position on our double lines, our parallel lines. This and this one here, they're corresponding. It's all about having essentially the same position on the two lines. So we've got our two lines, and it's the same position on our two lines. And they're equal to the same thing. So let's do some examples. So first, let's name the angle that is alternate to C. So alternate is within our Z, so alternate are essentially this little bottom one here. So we say F is alternate to C. Now corresponding to E, so corresponding is about the same position on our parallel line. So if this is it here, A would be corresponding, so we call it A. We call this our F shape as well. We can use this to help us calculate the size of angles as well. So Y and 37 are what we say are cointerior, and if we remember back, cointerior add up to 180. So Y equals 180, take away 37, and that'll give us this value, which looks about like it's going to be 140 or something. And that gives us 143. I want you to pause this and do this question and then come back. Okay, so X and 64 are corresponding. That means that they are equal. So X just equals 64 degrees. And our last example, so we're going to find the value of A. Now this looks a little bit like, ooh, what? That's confusing. But if we were to draw out these lines a little bit more, we could see here that they're actually parallel lines and that these two angles here are alternate. So we say A is 35 degrees. Hope that makes sense, guys. Remember, if you have any questions, please ask. But otherwise, you're going to just get into some practice questions. Thanks, guys.